All right, so in these couple of examples, we are going to review how to solve equations, but first we need to remember what are called inverse operations, or in other words, how we will undo one mathematical operation in the equations that we have. So the first thing, if we're trying to undo addition, the inverse operation is subtraction. So let's do a quick example of that. Down below here, I'll call that example 1. Let's say that we have the equation to solve a plus 5 equals 8. Notice that this equation does use the operation of addition. We know to undo addition, or something that is positive, we would subtract it or use a number that is negative. Remember, for an equation, we have to keep things balanced. So whatever you do over here on the left side of the equal to sign, you can only do it one time on the left and one time there on the right side of the equal to sign as well. So then that would leave A. The whole idea here of the inverse operation is that a positive 5 minus 5, that is a zero pair. In other words, they will eliminate one another. Then over here, 8 minus 5 is 3. So my solution would be A equals 3. Now, if we take a look at just the opposite here, we're starting with the operation of subtraction. Then the inverse operation would be addition. So we can just create an example that kind of goes the opposite way. This will be example 2. How about A minus 10 equals 7? So once again, we have our two sides of the equation, the left side which has the expression a minus 10, then the right side which just has the expression 7, and we are using a negative 10, or we're subtracting that. So to undo or eliminate subtraction, we will use addition, one time on the left side and one time on the right side. This creates another zero pair. Negative 10 plus 10 will in fact add up to 0. That leaves the variable a on the left side, and the answer, the solution, 17. It is in fact true that 17 minus 10 is 7. So that works there. Then, if we're using the operation of multiplication, the inverse operation of multiplication is division. Now, there are a couple different ways that we can show multiplication, so I'm going to pause really quick because I'm going to make the other examples a little bit smaller, then I'll be right back with that example. Alright, so now that I have a little bit more workspace here for example 3, one way that we can see multiplication is if we just have a coefficient. So how about we do this, 5x equals 20. Now, you don't actually see any multiplication in this equation, but if we have the coefficient of 5 in front of the variable x, it is understood that those two terms are being multiplied together. We're actually taking that 5 multiplied by the x. So now, since we have multiplication involved in our equation, once again, there are two sides, my left side and my right side. I will use the inverse operation of division on both sides. Now, this is not a zero pair. This time with division, 5 divided by 5, those just cancel each other out because 5 divided by 5 leaves us with a 1. We don't need to write the 1 in front of the x, because if you just write x, it's understood that you only wrote one of those down. So it's just the 1x understood without that coefficient. Then on the right side, 20 divided by 5 is 4. Alright, then for our last one here, if we have division, we would then use the operation of multiplication to undo that. So let's go to our final example here, example 4. And a division problem, I'm going to go ahead and write it using a fraction. So let's say the variable w divided by 2 equals 8. Now, just think about this for a second. Do you already know the answer? Do you know some number that divides by 2 to give you 8? So keep that number in your head, and then that should be the answer that we get at the end here. So if I separate into my two sides of the equation, left side and right side, we see that we do in fact have a division problem. That's what this fraction bar indicates. And to get rid of division, we use the inverse operation of multiplication on the left side and the right side. Okay, so now if you remember with fraction work, this 2 on the left side is really like a 2 over a 1 because it's just a constant of 2. And if there's a 2 in the numerator and a 2 in the denominator, those cancel because it's like the division problem 2 divided by 2, which just leaves us with 1w. Remember from that last problem, you don't have to write that 1 as the coefficient because that's just understood. Then over here, 8 times 2 is 16. So hopefully that was the number you were thinking of earlier. 16 divided by 2 is 8.